So we're live. We have William and Hal with us here today, and let's wait for a couple of minutes for people to join, both on LinkedIn Live and YouTube Live here. And so we'll just like chit chat a little bit about all the fun data tools at the meantime. And if you're already joining, please drop in the notes about where you're tuning in from. And I would also love to know what kind of ETL tools you're using at your moment. Drop a comment here. Okay, so actually before we go live and in the prepare stage, I was asking William a lot of questions about the difference in the open source data market in China versus US. And it was very different, and I was really fascinated. So I thought that everybody else might be interested to hear more as well. Before we go to the SeaTunnel presentation. So William, I asked that in US, I would say the most popular open source ETL tools here is Apache Airflow. It's really popular. I would say that's the one thing people come to mind when you're thinking about data orchestration and open source tool. Is that also popular in China?
No, actually no. Actually, the most popular orchestration tools in China, I think, is called Apache Dolphin Scheduler, and very few people use Airflow, and some people use Azkaban, but Azkaban is too old. So uh, I think more than 80% people are using Dolphin Scheduler now.
That's
It's
really
great.
interesting.
Yeah.
Okay, can you tell us a little bit more about why people choose Dolphin Scheduler over Airflow?
Yeah, I think there's two main differences. The first one, Dolphin Scheduler is designed for huge workflows. For example, more than 10,000 workflow. If you have a more than 10,000 tasks, perhaps Airflow will hit the limit. Then the Airflow will be slow or unstable. So many users have to build many Airflow clusters in their enterprise. So, they will have to divide the DAG into many pieces. But Dolphin Scheduler is the architecture of that Dolphin Scheduler is multi-master and a multi-worker. So the performance is very well. And so in China, there's a large population and the big data is huge. So the orchestration tasks are also very huge. So the performance will be the main issue that China users will met. So they chose Dolphin Scheduler as the first choice. And the second, I think, Dolphin Scheduler has a UI. And then you can drag and drop to create a workflow and to let people who only know SQL can drag and drop to create a workflow, and then you can see the data in the report. So it's good for people who only know SQL and they don't know Python. So so many users like such as Shein, there's an e-commerce company. They just migrate from Airflow to Dolphin Scheduler because of the performance and also because of the UI drag and drop to create workflow things. So it's quite different.
Yeah, when I heard about it, I was like this person in the comments said, I was mind blown because I just assume Airflow is popular everywhere. And this is actually super interesting because when I first joined Netflix, I was talking to somebody on the data platform team, and they told me that at one point they did evaluate Airflow to use at Netflix, but they did not end up adopting it because it did not scale as well for Netflix
Yeah.
size. And I'm going to I did some research last night. I'm curious, like how Airflow scale and where's the bottleneck is. I actually found a presentation given by a engineer on the data platform team talking about how they evaluate Airflow and what kind of problem they run into and why they didn't end up using it. So I'm going to drop it in the linking comment. If you guys want to read more later, feel free to, but it's super fascinating. Anyway, okay, we're at 10:05, so let's get started. So today, it's my honor to have William and Hao at this DET webinar today to talk about the modern EtLT architecture and Apache SeaTunnel. So before we get started with the presentation, so William and Hao, can you give a self-introduction about yourself to everybody?
Well, of course. So thank you, Xian. And I'm William. And I am Apache Software Foundation member and also the PMC of Apache Dolphin Scheduler and Apache SeaTunnel. And I used to work at Teradata and IBM and Lenovo and Wanda. So I just worked in big data area for almost 20 years. So that's my introduction. So Hao, it's your turn.
Cool. Thanks, William and Xian. Hey guys, I'm Hao. I'm currently an engineer at JP Morgan. I'm in the merchant checkout team, like payment organizations. Mostly I'm working on with like data infrastructure and pipelines. Before JP Morgan, I worked at a firm. I'm actually was in the ML platform team, but working a lot with the data as well. And yeah, it's just my past career is more in the fintech area, like dealing with those massive data.
Yeah, fantastic, William and Hao. Thank you for the introduction. So without further ado, I'll give the stage to William to start the presentation on SeaTunnel.
Okay, thank you, Xian, and thank you, everyone. And I'll just make my presentation. This is me. And for the content, we will discuss about 4 parts today. The first is what is Apache SeaTunnel and the ETLT architecture. And the second is why we need a SeaTunnel. And the third is a real-world use case for SeaTunnel. And the fourth part is why JP Morgan chose SeaTunnel for data ingestion. So the first, I want to introduce the ETLT architecture. Everyone knows ETL, extract, transform, and load. And I heard that architecture when I was in Teradata and IBM. At the time, we just extract data from Oracle or Sybase or DB2, then use transformer tools such as Talent or Informatica. And then we load the data into Teradata or Oracle under data warehouse edition. And then big data era comes. We just extract data from ORTP database and then load them into Hive or load it into Hadoop. Then we use HSQL or Spark SQL in our Hadoop or HDFS. But now we have lowercase t and ELT architecture. Why we have a lowercase t here? We just extract data from a traditional database, but now we have more challenge. For example, we want to build a real-time data warehouse. We cannot extract data only from JDBC. We have to use, we call the technique called a CDC. That means change data capture. We have to analyze the bin log of Oracle or analyze the bin log of MySQL. And then we do a small transform and then load them into Snowflake or Redshift or other data warehouse. Is not like the old days. We just use the JDBC, and also now we have numbers of database. For example, the cloud database, Aurora on AWS, or Neo4j for graph database, or InfluxDB for time series database. And also we have lots of SaaS API and some message queue like a Kafka or Pasa. So it's very hard if you just use extract and load them into our data warehouse, because you have to do some normalization or do the type transformation before you load them into the Snowflake or other data warehouse. So there will be a lowercase t here. That means you extract the data from the source database, and we will have to do a small transformation, and then we load them into the data warehouse, and then we can use we call the uppercase T. That means we can use SQL language to do the transformation. So, for example, you can use a DBT or use Databricks to do the transform, and the lowercase transform and load, the data engineer or ETL developers or data architect will focus on how to extract data and do a small transformation and load them into the data warehouse. And the SQL developer or AI scientist or other data analyst will do the uppercase transform with SQL language. And also we have an AI developer use the data from the data warehouse. So I think the architecture will transform from ETL to ELT and then ETLT. So that's an ETLT architecture. So what is Apache SeaTunnel? We call it next generation data integration tools. Actually, I think it's a lowercase t l tools. And now it has star over 6,400 stars. And what is SeaTunnel? SeaTunnel is very simple. It's just synchronized data from the source database to your target database. But the source database, it can support many kinds of database. For example, MySQL, Hive, Redis, Kafka, Elasticsearch, HBase, and AU4G, EtLT. There's just many kinds of source database. And also, it can sync data to the targeted database. It can be Snowflake, or it can be Kafka, or it can be other SaaS or other software you have. And there's a data integration engine we call the SeaTunnel Zeta engine, or you can use a Spark or Fleek as a data integration engine. And now SeaTunnel has more than 160 more than that connectors, and the performance is very good. And the connector grows almost doubled for each year. So this is the concept of Apache SeaTunnel. And let me tell you why we need Apache SeaTunnel. Actually, before we create Apache SeaTunnel, we use Apache Scoop or Apache Flume to synchronize data from your log file to your Hive, or from MySQL to Hive or to other database. And we found that the connector is too limited, because we have more and more cloud database and other NoSQL database. And then we try to use Spark and Flink to do the data synchronization. And we found that it's very hard, because you have to write the connectors again and again for different database. And also we need some feature in data synchronization, which which Spark is not Spark or Flink cannot support them very well. So now we have Apache SeaTunnel. Apache SeaTunnel has some features. For example, it supports more than 100 connectors, and it can support database, cloud database, message queue, such, and there's many, many connectors. And SeaTunnel has a very good performance. If you have a large volume of data and want to sync them between different database or between different cloud, you can choose SeaTunnel as the tool for to do the synchronize. And also SeaTunnel is very stable. Actually, I just use AWS DMS before, and to do the synchronization from AWS Aurora to AWS Redshift, and also from MongoDB to AWS Redshift, and we do it in CDC mode, the real-time mode. And I don't know why the DMS is not very stable. So I have to find other tools to do the same thing. And at last, we found that either we have to write the connectors with in Flink, or we have to create another open source project. That's a SeaTunnel. So SeaTunnel can support a large volume of data to do the synchronization. And also, SeaTunnel can support batch mode and real-time mode. That means you can extract data and load data to your target database in batch mode. And also, you can use CDC, that means real-time mode, to extract data and load them into your target database. And also, it supports multi-table synchronization. And SeaTunnel is very easy to deploy and use. It didn't deploy HDFS, Flink, or Spark. Or you can use Flink Spark as the computation engine for SeaTunnel. But if you don't, you can just deploy SeaTunnel with data engine. So it will be very easy to deploy. And SeaTunnel also support SQLite code to do the transformation. And also you can use UI drag and drop to create a data pipeline. So for programmers or for the data analysts, I think is user friendly. And also SeaTunnel support multi-cloud from AWS to Google Cloud or to Ali Cloud or to Snowflake, and it can support multi-cloud synchronization. And also it has more features such as schema evolution, resume at breakpoint, and more features are in SeaTunnel roadmap. So first I want to introduce the connectors about Apache SeaTunnel. Here is the list of Apache SeaTunnel. It can support more than 130 connectors. You can see there's many cloud database or open source database like Cassandra or IoTDB or InfluxDB or Hive, and also it can support some SaaS connectors, for example, Notion or Google Doc or other things, and also it can support some message queue such as Kafka or Parsa or RabbitMQ. So I think the connectors of SeaTunnel are most of database, and there are some SaaS connectors. And if you want to know the database you are using is supported by SeaTunnel, you can search SeaTunnel connector on Google, or just you visit the seatunnel.apache.org. Because it's open source project, so it's free, and it's Apache Software Foundation projects. And in the last version of SeaTunnel, I found that a very, very interesting feature. And one of the contributors of the SeaTunnel contribute a feature called AI compatible, because now SeaTunnel has many connectors to connect database to database, and actually many people want to have the connectors of a SaaS, and this contributors contribute this AI compatible feature, and he just refactored the SeaTunnel engine API, and then it can let ChatGPT can write the code for the SeaTunnel to create a SeaTunnel connectors. And database connector will be more complicated, but the SaaS connector somehow is easier. So these people write this feature and gave us a demo that can let ChatGPT to read SaaS API document, and then prompt the ChatGPT and give him the sample code, and then he can generate the connector code from ChatGPT. And I just tried this this demo, and it works. It just gave me the a GitLab connector, which from GitHub connectors. So I think it's very interesting because this idea is very amazing. SaaS will be thousands of APIs, and if people have to read the API documentation, that wastes our time, and I think it's a labor work. So these people I think these people want SeaTunnel to be the next AI generated Airbyte or Favtran. So it's a very interesting idea. And I tried this demo. I found that there's it's very interesting and it's amazing. But I think there's two flaws in this version. One flaw is I think the SaaS API now it can handle with the simple SaaS API. If the SaaS API is complicated, so I have to learn some more complicated prompt words. So I'm not prompt engineer, so I'm not familiar with that. So when I try to use to create a Salesforce a connector for SeaTunnel, I have to talk with ChatGPT for a long time. So sorry, but I think this engineer will upgrade the whole API and let ChatGPT to write a more complicated SaaS API for SeaTunnel. And the second flaw is because SeaTunnel is not like Airbyte or Fivetran. So SeaTunnel can read the data and from SaaS API and just transform them into a JSON, something like that. And you have to do the mapping from JSON to the we call the virtue table. So there will still some labor work that I have to do with SeaTunnel AI generated API the connectors. So but I think in the future perhaps ChatGPT can do this for me. So this is a very interesting feature that I mentioned because these people let ChatGPT to generate the code of SeaTunnel for the SaaS connectors. So that's a very interesting feature. So talk about the better performance. There's some performance test here, and everyone knows Fivetran and Airbyte, and they just do a performance test use SeaTunnel versus Airbyte, and found that SeaTunnel is 30 times faster than Airbyte. And if you want to see the details, you can search SeaTunnel and Airbyte on Google and find some report by some contributors. So you can see that SeaTunnel is very useful for the database synchronization, while Airbyte and Fivetran is very useful for SaaS data ingestion. So that's I think it is the product is different. And also, if you are using AWS, there's a report performance report about SeaTunnel and AWS Glue, and you will find that SeaTunnel is 4 times faster than Glue. I think because SeaTunnel engine is the performance is very good, and SeaTunnel is not like Spark or Flink. It's just designed for the data synchronization. So when I use SeaTunnel, I will find that the CPU and the bandwidth SeaTunnel can use them very effectively. So I think SeaTunnel is very good at synchronization between different databases. And also, there's another open source project called DataX, and here is a report that SeaTunnel is 30% faster than DataX. So if you want to see the detail there, you can search the report on Google. So so the SeaTunnel is very easy to deploy if you want to try them. There's articles that you can deploy the Apache SeaTunnel in 3 minutes. Actually, if you want to try Apache SeaTunnel, first step, you just set a Java runtime environment and then download the latest SeaTunnel, and then you can install the connector plugin because there's so many connectors. So you have to choose which connectors you want to use, and they download and they install them into SeaTunnel. And then you can configure SeaTunnel. This is SeaTunnel configuration files. You can see I will introduce this kind of thing in the next slides. You can configure SeaTunnel, use SQLite language to do the synchronization to things. And then in the 5th step, you can run the SeaTunnel job. And the whole thing is very simple. Not like a school for Goblin. SeaTunnel don't need HDFS or Spark. So it can run standalone mode, and also you can use the other things you can use one server or several servers to run the SeaTunnel projects. And now if you want to try Apache SeaTunnel, I strongly recommend that you use version 2.32 or 2.3.3 because I think there's less bug than before. So if you want to try, you can download this version. And SeaTunnel is stable and can synchronize data just exactly once. The first SeaTunnel is designed decentralized, and that means you can do the online expansion. And you can scale up or scale down, and the engine will and it will not affect your job you're running. For example, you just ran a CDC job from Aurora to Redshift, or AO4J to Redshift, and you scale up. The whole thing will the data will rebalance in when you are doing this kind of thing. So it's designed a decentralized design will help you to scale up and scale down. And SeaTunnel can assure the data exactly once from your source database to your target database, because it has a global checkpoint. It also has a distributed snapshot algorithm, and I think it called independent rights. I don't know whether it is spelled like that. And also it had two-phase commit, ensure that each piece of data is correctly to insert the target database. And it can also resume at a breakpoint if you are doing an offline job, when you break from the synchronization, it will roll back to the checkpoint before and do the whole things again. So you needn't to worry about the data will lost or data will double. So it's a very good design for Apache SeaTunnel. And how to use Apache SeaTunnel? You can create a synchronized data with SQLite code. Here is an example. SeaTunnel has three parts. The first part is a source, and then you can do the transform, and then you can do the sync. So here is an example that this is a configuration file for SeaTunnel. You can design the environment. For example, here the parallelism, it means how many jobs, how many pipeline you want to use in your synchronization process. Parallelized 2, that means you can use 2 CPU cores to do this synchronization job. And also the job mode is batch. And then you can define the source. For example, this is the source from IoTDB. You can use the username and URL. And also you can use the SQL in the IoTDB. And if you want to do the transform, you can also use the SQLite language to do the select or replace or other things, and to do the transform. And then you can use the sync. Sync is also like a SQLite language. Now the sync is cancelled. Now the transform is here, but I think the transformation is quite different from a Spark or Flink, because Apache SeaTunnel is a tool to do the synchronization. The transform is only support some, I think it's called normalization, because you cannot do the join aggregation, or you cannot group by something in your transform. SeaTunnel only support to select to do the record transformation. So it cannot support the aggregations like Spark or Flink. So that's why SeaTunnel can run in a better performance, because it's only designed for synchronization. Sorry. And if you want to create a synchronized job with UI, and you must deploy another project called SeaTunnel Web. And SeaTunnel Web is a web project for SeaTunnel engine. And then you can, if you deploy that project, you will have a web interface for SeaTunnel. And here is several steps for create a synchronized job with SeaTunnel Web. First, you can create a data store. Oh, sorry. And the second, you can create a virtual table. Virtual table here means, in your config file, you can use a select to do the to transform data from JSON to the target to the virtual table. But if you just extract data from Kafka or from SAS API or from NEO4j, perhaps you have to create a virtual table. Virtual table is mapping JSON or any unstructured data to structured data. So the structured data, we call it virtual table. So you can just do the mapping from your JSON to the virtual table. Here is an example for the Kafka. So you can choose a topic, and you can choose the JSON structure, and then you define them into a table, column, or field type. Then you can do the synchronization from Kafka to any database you want. And then you can create the whole process from you can create a source and create a sink, and also there's a transform items. You can just drag and drop and to config them in the UI. And here is a data mapping. Every transform will have this function. You can do it in input table structure. It means uh, uh, what kind of data from this input side, and for the output side, you will have from this side, and you can use, for example, if you use the copy transform, you can copy a column from the source type to a source table structure to your target table structure. And also, if you have other field mapper, replace, or SQL, you can use similar things to drag and drop to create a data mapping. And then you can run the whole job. No matter there's two kinds of task. One is we call a batch task. That's just like do something like a swoop. You just use a GDBC and just you insert into your Snowflake. And also we have a real-time task. That means you can use a CDC and uh, to analyze your bin log and then insert into your Snowflake or Redshift in real time. And here you can see how many the speeds of the synchronization task. And also you can see the result of the synchronization task. So it's easy for you to create a synchronization job with a drag and drop. And if you are a data engineer and you like to write a program, you can use the SQLite program to use to do the synchronization. And I think it's more function is in the SeaTunnel roadmap. For example, now SeaTunnel will support schema evolution. That means if you have a DDL in your source database, for example, you alter table in your MySQL, then SeaTunnel can do the same thing in the target database, for example, in Iceberg or in Snowflake. And then you can synchronize data in all time. When the source database changed, you needed to stop the ETL process, and you needed to modify the ETL program. What you do is just use the schema evolution. Then you can let the SeaTunnel to do the DDL update from a source to the target. And also, it will support multi-table synchronization in one data pipeline. That means if you have for example, I have a 1,000 MySQL table, and I want to synchronize them into Redshift. I can just click or just select this 1,000 table, and I needed to create 1,000 jobs. So this feature will be supported, I think, in the next half year. And also, there's a feature called auto create table. That means you can create table before synchronization in batch mode. I will use the example also for the 1,000 MySQL table, and now I want to synchronize them into Redshift, and I don't want to create the table in Redshift because the table is the same, the name is the same, or the name will have a prefix or before the table name, and I can just use the auto create table feature to just create thousands of table from your source database in your target database. So it's a very interesting feature. And also it's another feature called save mode. Save mode means save model. That means you can choose how to deal with your data in your target database. For example, perhaps when you do the synchronization, the targeted database will have the same table versus the source table. And how to deal with the data in the target table. You will delete them or truncate table or just update the records. So you can choose the save mode in the synchronization. So I think there's some features that SeaTunnel will support in the next half year. And the whole community is very active. And this is a GitHub training this week. You can see in Java program, SeaTunnel is the fifth active projects for in GitHub. So I will tell something about the use case about the SeaTunnel. Actually, here is the architect of EtLT for DataOps. And in real world, actually, we will use two ways for the data process. The one way for data process we call the real-time data, and SeaTunnel can extract data from IoT DB or IoT device, or can use the CDC. We call it change data capture from the database, such as Oracle or MySQL. And also it can read the log or the SAS API. Then it can synchronize data with the SeaTunnel engine. You can synchronize data from this source to the Kafka. And you can use other application from to consume the data in Kafka, or you can use the SeaTunnel connector to real-time load to your real-time data warehouse, such as Redshift or ClickHouse or Elasticsearch, and then you can do a real-time dashboard on this kind of real-time database. And also, you can use the SAS API to let this data, to let SeaTunnel to synchronize data from a source into your SAS. And also, we have another type of data process we call batch time data. And SeaTunnel can extract data from a file, from message queue, from a database or cloud database or NoSQL database, and then load them into your data lake. Perhaps you are using Hudi or Asper. And if you're using Hudi and Asper, SeaTunnel will support schema evolution in the future. So you needn't to care about the schema change. So the SeaTunnel will handle the whole process. And also SeaTunnel has some connectors has the feature of multi-thread or batch load mode. For example, you can use the multi-thread to load data from Oracle or from file to your Hive, different partition, or multi-thread to load the data to Teradata or Snowflake. And also, if you are using OLAP engines such as ClickHouse, Doris, or Drilled, you can use the batch load mode. For example, we have a batch load connector for ClickHouse. That means when the SeaTunnel inserts data or append data to ClickHouse, it is not using the JDBC connector to load the data. It just writes the data file of a ClickHouse, and it will read the metadata of a ClickHouse. For example, if ClickHouse have 8 clusters, and SeaTunnel will write the ClickHouse data file in this 8 servers, ClickHouse servers. So the performance will be very, very good for if you have a large volume of data. So this feature we call the batch load, where you can call it bulk load. So this is some connectors support to load the data to your target database very quickly. And also we have some orchestrators. You can use Airflow or Dolphin scheduler to handle with a SeaTunnel job. You can control the real-time job or the batch load job in your orchestration tools. And also SeaTunnel support reverse ETL because SeaTunnel has so many connectors. You can just extract data from your data lake and load them back to your Oracle, MySQL, or back to your SaaS. So some people call it reverse ETL, but for SeaTunnel, it's only a different connector support this kind of feature. And also you can load the data back to your Amazon, to S3 or Azure or Google Cloud. And this is a SeaTunnel connector can support that. So some cases in SeaTunnel real world. This is a case in Shopee. Shopee is an e-commercial company in Singapore. And here is the architect of Shopee. Shopee have a Kafka and has InfluxDB, have a Flink, have a Drilled and DataHub. And Kafka and Shopee just use SeaTunnel to synchronize data from Kafka to InfluxDB, and also from Kafka to DataHub, and also DataHub to Drilled and Kafka to Drilled. So if you want to know the details, you can search Shopee and SeaTunnel in the Google. You can see the details. And also, there's another e-commercial company called Xiaomi, actually, and the whole Xiaomi use AWS cloud, and it use Aurora MySQL in AWS, and also use MongoDB. And this company want to synchronize data from MySQL and MongoDB to Redshift, and they tried AWS MS before, but MS is not stable, just like what I found. And then they use SeaTunnel to do the synchronization. And the result is they use 4 hours to initialize about 400 million records from MySQL to Redshift. Because when you do the CDC mode, you have to use the initialized mode at first, because there are too many records in your database. You have to do the initialized process, and then SeaTunnel will automatically shift from GDC mode to CDC mode when the initial process finished. So they just use MySQL CDC to Redshift with SeaTunnel. And also they use SeaTunnel to do the MongoDB CDC to Redshift. And if you are using Redshift, Redshift has a data type called super, and MongoDB will mostly have the column will larger than 64 KB, and in Redshift, most of the data type will not support that kind of data type. So SeaTunnel can transform the data from MongoDB to Redshift from MongoDB data type to the data type super if the column is more than 64 KB. So it's a very useful feature if you are using Redshift and want to synchronize data from other database to Redshift. And also there's another case for the name is Youzu. It's a game company, I think, and it's just build a real-time data warehouse with Hive and Storrocks and CeaTunnel, and they just extract data from Kafka uh, directly to the Storrocks. Storrocks is a OLAP engine, just like Redshift, but the performance for the real-time computation is better, I think. So that they just use Kafka and CeaTunnel just to do the real-time synchronization from Kafka to Storrocks. And also they have a batch mode. They just use Kafka and use CeaTunnel batch mode to load data from Kafka to Hive, and then from Hive to Storrocks. And they have a real-time report in Storrocks. So this is a use case in Yuzu. And for my part, I just introduced you the real-time use case, why we need CeaTunnel, and what is CeaTunnel, and what is EtLT architecture. And here is my linking. And thank you everybody for my part. And now it's for Hao part. How is your turn?
Yeah.
How are
Thanks.
you ready to present?
Yep.
Okay. Cool.
Can you guys see it?
Yeah, I can see it.
Cool. Yeah. Let me just get started. So some background about like why we are using CeaTunnel and how we use it. So first is like JP Morgan is kind of really giant company, but contains a lot of big legacy systems. I think you definitely know it from like this perspective that old banking companies just doing some old stuff, but still like as far as I know, it's like there are 200K employees, have 30K plus data gurus like engineers, analysts, and scientists. And as far as I know, there are more than 10 plus different data platforms across many organizations in the companies. You can try this, try that. But still, if I want to ingest some data, like some basic data, I still need to write an JDBC interface to do it. So why is that? First is like the privacy consent. Um, there are many layers of like access control to before you to be able to like ingest the data, and the sharing the data between different teams and orgs can be like really hard because like they're caring about the data about the privacy data, so there are a lot of like safeguard to make sure you use it. That's why like when I want to use some tool to ingest data, I need to get a lot of permissions and until I am able to do it. And another one is like the company kind of lack of the data infrastructure foundations. The company actually on the roadmap to migrate to AWS like around 2 years ago started, but still like on the way to do it. But also it trying to open to some like new options like Snowflake as Databricks. Those are really kind of new things coming to the companies, and we're kind of working on how to integrate it. So because of those two reasons, so if as our team want to kind of integrate the data sources and quickly wrap up like a solution to be able to ingest data, we have to either write like some customized code ourselves, or we wait for maybe about half a year until we get on board to some like data platform to use. So that's why we're seeking some solutions quickly and to be able to ingest our data sources. There are some options we evaluated. Like first is Fivetran. This kind of really popular cloud service, and like I work at a firm before and some other company. They both use the Fivetran. I think the problem to use it it's like vendor options, and we have to go through the procurement, and it's going to be super slow. Another one like Airbyte, it's open source, it's great. One thing about it is like it doesn't run on any like big data processing engine like Spark or Flink. It actually runs on like Airbyte workers. You can maybe choose their cloud solution. They might provide like more scalabilities, but that cloud solution needs procurement again. So we still want to find like an easier way to run on my more scalable engines like Spark to meet our use case. So then we think there is another one called Apache SeaTunnel. It's great. It's like open source. It also can run our Spark cluster. And one small thing note is like you can actually directly build and deploy on your Java code base. So GP work is kind of rely heavily on the Java code base. So we have a lot of tools we can use from there. So that's why we want to be able to trigger the job, the ingestion job, or like data migration jobs directly from our Java code base. That's kind of like a niche benefits with using cTernal. We also have like use Google service as well. We also crawl the data from like a data source into Google and into Athena. One thing about that is it's more like work with some specific like use case. Instead, it doesn't have a lot of customization for you. So if you want to like specify some schema change or some like a tab change, that's more like a one thing more hard like if you use Google. So kind of in combination of these two ways. So the architecture for our like use case is kind of simple. We have like some data sources like a PostgreSQL, DynamoDB, and blah blah, blah, as well as like SFTP files. We use cTernal to ingest these data sources and running on a Spark cluster, and then load these data into S3. It's more like our centralized data store. And from S3, we also ingest the data into Snowflake for some additional analytics works, and also use Google into Athena as well for different purpose of analytics. Elasticsearch is something we're also working on to be able to do some search use case. So cTernal is like a really helpful integration in there to I really like it. It's like a language dialect, so it kind of converting the types explicit for you. You can figure out, hey, what's this type from this PostgreSQL mapped into S3 into Snowflake. That way, you will have like a good control to see if I date is in this format and I convert it to when I ingest into S3, what format it is. Is it UTC? Is it like become like a pure string or something like you really want? You can actually customize it. Yeah, this is our team's architecture for this project. We're still like on a batch mode, and that's something we are thinking in the future. We don't have like a really big requirement for the latency, but in the future, maybe when we do some like use cases like recommendation or search, we'll think about like maybe we can try some like other engines like Zeta engines or Flink clusters to improve the performance. That's one thing on the roadmap. Another one is like we also want to ingest more data sources. Since cTernal also supports Kafka and something like AWS QS, we were thinking about to add to our like this integration service. And we also think about contribution back to the project. There are some like there are some new platform like a Databricks coming to the companies. So we're thinking about maybe we can do some contributions over there to include more processing engines like Databricks or maybe some other like the AWS services, and more data source connectors. There are still like some data sources connector not like implemented yet, I think that's a really a good place to be contributed to. And web UI, I think the SeaTunnel is getting there, like web UI work out soon, and that's will be really helpful for us to monitor and tracking the jobs. I think well, more information you can go to the SeaTunnel document and join our communities.
Yeah, thank you, Hao, and thank you, William, too, for the presentation. So we're actually right on time at 11, and I see that Hao already replied to some of the questions on YouTube and LinkedIn. So we're just going to wrap up here. And thank you, everyone, for joining, and I hope to see you at a different webinar in the future. Bye, everyone.
Thank you.
All right.
Bye.
Thank you. Bye-bye.